Hello students, here in this video I am going to explain about how to measure the pressure of liquid flowing through a pipe. In our supply of water, in oil supply pipes, we have to measure the pressure of liquid so that if there is a problem or accident takes place or any bursting of pipe takes place, then the accidents may be decreased. Let's come to that how to measure the pressure. There are two types of devices. One is manometer, another is your mechanical gauge. The manometer is divided further into simple manometer and differential manometer. Simple manometer again divided into piezometric, U-tube manometer and single column manometer. Another is differential manometer. Differential manometer is of two types. One is U-tube manometer, another is inverted type U-tube manometer. The mechanical gauges further subdivided into diaphragm pressure gauge, bottom tube pressure gauge, dead weight pressure gauge and billows pressure gauge. Now go for study about manometers. Let's come to the first part of simple manometer, that is piezometer. A piezometer, as shown in the diagram, we are having a right angle bent tip whose one end is open to the atmosphere, another end is attached with the pipe where we are going to measure the pressure at point A. This is the pipe. The cross-sectional view of the pipe is your circular type, hence the pipe is shown as a circular surface. The bent tube right angle type is attached with one end to the point A, another end open to the atmosphere. The pressure inside the liquid is more. Now, while we are going to attach the glass tube with the pipe, there we are finding that due to the high pressure inside the pipe, the liquid raise up inside the right angle tube. And let's consider a reference line, considering center line x-axis as the datum line or reference line. We are observing that there is a h height or level of liquid rise up from the datum head is h. Considering rho is the density of liquid flowing through the pipe and h is the rise of liquid, the pressure at point A due to the pressure of pipe, the liquid enters into the tube. So PA is equal to rho GH. So in piezometer, the pressure is measured as a positive pressure only. If you are considering the vacuum pressure, then it cannot be measured, because unless until there is a rise of liquid in the tube, then we cannot measure the pressure. So piezometer is only useful for positive pressure. Let's come to the limitation of piezometer. From piezometer, we are going to measure only positive pressure. But if the pressure of liquid is more, then the rise of liquid will be more. So to accommodate that rise of liquid, we have to construct a large glass tube, but which is not practically possible. There may be inconvenient to carry that pipe. So there is no high pressure cannot be measured. Another is vacuum pressure. As I have already told you, the vacuum pressure cannot be also measured, because if the pressure inside the pipe is lower than atmospheric pressure, and so the atmospheric pressure causes the pressure upon the liquid, so that the rise of liquid may not be takes place, and due to that the pressure cannot be measured. Now, to modify or to rectify the measurement of pressure, that we can measure both positive pressure and negative pressure. Hence, we are going to use another form of manometer, that is U-tube. As shown in the figure, we are having a pipe. It is seen as cross-sectional view. It is a circular cross-section of pipe. There is center point A. The pipe is connected to a U-tube, and this U-tube has two limbs. One is left limb, another is right limb. The right limb is open to the atmosphere. The left limb is connected to the pipe. Now, the manometric liquid, initially it is present inside the U-tube, and the manometric liquid taken as your mercury. Let us consider there is a datum line. Where you have to choose? The datum line should be chosen at the point of interference between the two liquids. The coincidence of two liquids are there, and at that point we have to draw the datum line. From this datum line, we'll measure the pressure at point A inside the pipe. The area of pipe is more. While you are entering the left limb of the U-tube, there is a rise of liquid takes place, and the liquid enters into the U-tube, and that will forces the mercury in the right side. If you are going to measure the positive pressure or high pressure, the high pressure of liquid will be causing the mercury to move in the right limb. The total height of mercury in the right limb is Hg. The rise of liquid in the left limb is H1. Rho is your density of the liquid. Rho 1 is your density of liquid in pipe. Rho G is your, or Rho 2 is the density of mercury in the right limb. We know that at the datum line, point B and point C, where the pressure at left limb at point B will be equal to pressure at point C in right limb. Why? Because both the B point and C point are on the datum line. Hence, we are going to equate the pressure PB with PC. Now, what is the pressure at point B? Initially, the pressure at liquid inside the pipe is PA. Due to the rise of liquid H1, this is rho GH, so rho 1 G H1. The pressure at point C, that is only the height of liquid, that is rho 2 GH2. So now the pressure at point A can be obtained as PA is equal to rho 2 GH2 minus rho 1 GH1. Let's go for the negative pressure measurement. As shown in the diagram, we are having the cross-sectional view of the pipe, inside which the liquid is present, but the liquid pressure is lower than the atmospheric pressure. Now what happens? As we have right limb is open to the atmosphere, hence the atmospheric air will be applying a force upon the mercury. So those case in your positive pressure measurement, the total height of pressure is measured in the right limb will be found in the left limb, and that height of mercury is equal to Hg, and the height of liquid in the left limb is H1, and the rho 1 is your density of the liquid in the pipe. We have seen that at point C there is no liquid, so the pressure at C point PC is equal to 0. Similarly, at the datum line, point B, the pressure is equal to, due to density of mercury, it is rho 2 GHg. that is equal to your pressure of liquid in the left limb plus rho 1g H1 due to the H1 height. So PA plus rho 1g H1 plus rho 2g H2 is equal to PC is equal to 0. So PA is equal to negative of P2g H2 plus P1g H1. So negative mark sign that this is a vacuum pressure measured at 5. Thank you.